Hi everyone, my name is Adnan Hodzic, or Hodzic for all the Balkan people here. I've been with ING for more than 4 years, where I work as a lead site reliability engineer as part of a public cloud team at a data analytics platform as part of Amsterdam. This talk covers ING machine learning platform migration journey, or a battle to Kubernetes, which took over 2 years. And what initially started off with a lot of resistance that lasted throughout the process ultimately resulted to be the only right choice for us in the end. Just to set up your expectations, won't focus too much on technical implementation details, but will instead focus on giving a high-level overview to answer some of the questions I had and was looking for in KubeCons, and to provide some guidance if you're in the same situation in your company. And just so there's no confusion, while I'm part of the public cloud team now, this talk revolves around my time in the same role at MLP team. And since I'll be saying MLP a lot, MLP is an acronym, the clicker. MLP is an acronym, stands for Machine Learning Platform. So please keep this in mind because I'll say it a lot of times. So our premise takes place at ING. ING is one of the world's biggest banks, definitely the biggest bank in Netherlands. It has around 60,000 employees, 18,000 of them work in tech, offices in around 40 countries, and serving around 38 million customers. Now, this is a case in many environments, but especially banks, since we work in a highly regulated environment and are subject to rigorous policies in terms of risk, security, change management controls. It's not as easy to deploy our workloads to production. What's even more complicated, if you're a data scientist who would like to do the same without any underlying SRE or deployment or infrastructure knowledge, and that's where MLP steps in, as it will allow data scientists to seamlessly deploy their machine learning model to production while abstracting all of this underlying complexity from them. And it will, in the end, it will serve as a model hosting platform. Setup consisted of Python ML models being wrapped into Python containers, which then, along with other services, are part of the Docker Compose files. And then these Docker Compose files are deployed to various and numerous VMs using Ansible. You could say that things work great, but I thought the missing link in this whole picture was that it was not running on Kubernetes. As by observing how things were architected and set up to work in existing VM setup, I immediately thought we'll have a problem with scalability, as in growing at scale. Something that could be fixed by Kubernetes, of course. And since I did use quotes around work great, here's the list of the problems and annoyances we had in existing setup. So ING being a bank means it has very little appetite for risk. So besides bi-weekly patching cycles, we had a constant influx of risk work, maintenance work, and some other things that we just had to act upon. And this took a lot of our time. And what made this problem even worse is that VMs were treated like pets and not like cattle. So if something went wrong with one of our VMs, we could, or whole environment of VMs, we couldn't just get rid of it and start over from scratch, because you don't want to get rid of your pets, right? Joking aside, due to not being able to seamlessly reprovision our VMs from scratch, made us extremely careful not to misconfigure any of those VMs. So this made the whole deployment and development process very lengthy and also error-prone. To combat this problem, I developed a tool called Chameleon, which allowed us to mimic prod or any other environment's target setup as part of a local container. So now we could be more creative with our code. We could see if certain things worked for that target environment before those changes even hit that target environment. We could even adhere to infrastructure code principles, although in a very limited context, but still. And now, instead of having to commit our changes, push our changes, create a pull request, wait for that pull request to be approved, and then for the changes to be merged, one of the pipelines to pick up those changes, just to see you have a syntax error half an hour or an hour later. Now we had an immediate response loop. So if something was wrong with our code, we could see it immediately. And this made things drastically faster, at least in the terms of development and deployment. And related to what I said in one of my previous first slides, actually, now it was evident to everybody if we had an exponential growth of MLP in number of models that was being onboarded, getting all this infrastructure provision, getting it all configured, it would take a significant amount of our time. And now it wasn't just me saying it, now it was a known risk on the horizon, and it was a fact. And then we had a large number of unplanned migrations, not something that we were trying to do, but it was something, again, that we just had to act upon in order to keep our workloads running in compliant and secure manner. And again, it took a lot of our time and effort. And by this point, I was treading very lightly to even make a Kubernetes a proposal. But here are some of the things that you might think of if you're thinking of doing the same and making a Kubernetes migration a possibility. So containerize everything. Well, that you can containerize. There are certain things that maybe you shouldn't containerize, but otherwise just do it. Even if you're not thinking of moving to Kubernetes, if you're using containers, it could make your lives easier. And also by adopting microservices architecture should do the same. Also in the future, if you do decide to move to Kubernetes, it's going to make your setup future-proof. Or not even Kubernetes, to any other container orchestrator. And this is not the future. This has been the present for years now. Even Linux desktop apps are becoming as containerized workloads. For example, snap packages, which I also use to package one of my private Python apps. Because if you think about it, what better way to handle a Python application with a bunch of its libraries that in this form factor will work regardless of where you ship it to or deploy it to. And this should be obvious, but the more open source or CNCF software you use, the better. For example, our monitoring stack, which was using Prometheus, getting this migrated from VMs to Kubernetes was a breeze. And also with open source software, if you have a problem and you know how to fix it, you can simply create a pull request. So this way you fix your problem, you contribute back to the project you're using, you're benefiting the whole ecosystem. So I think it's a true win-win scenario. And spread the principles of SRE and share the knowledge among all team members. Think of this as if you were creating a soccer or football team. And I know I lost half of you that I said this, but please hear me out. Idea here is that only one person can be like a striker or a goalie, but that anyone in the team can come and be a striker or defend the goal in absence of another team member, or even play in a different position for the time being, but while still adhering to their expertise. Some people just have more affinity or experience towards kicking the ball into the goal. So to draw in a parallel with MLP team, while it mostly consisted of software engineers, we worked in the same way, that whatever was on the board, that could be picked up by anyone, but while still adhering to our expertise. As some people, if they have more experience in this field, they could lead these stories. I think this is just a nice way to work, regardless if you're migrating or just doing daily tasks. And document everything. I used to be one of those code is our documentation people. Like, not anymore. It proved to be very valuable to have things documented before, during, and after the whole migration process. Also, this way, besides spreading the knowledge, it allows you as an expert to move on and do other things. So now a software engineer who never did disaster recovery can do a disaster recovery by following your guidelines. Also, documenting also means that creating design pages. So everybody on the team is on the same page before the big changes are even made and before you even get to coding. And so, since by this point we were doing all of these things and many more actually, I thought, why not just make a proposal that we move to Kubernetes? And this is where this saying comes in, where an idea is only 5% and the rest of it, 95%, is execution. And here's why. Things are probably different now if you suggest to your team, hey, we should move to Kubernetes due to reasons. But when I suggested it, pretty much nobody was on the board. Maybe one guy was on the board. this guy. But the main reason was that things just worked in current setup and that we wouldn't really benefit by moving to Kubernetes. So while I was definitely bummed by just what happened here, to say the least, I thought it didn't happen due to some malevolent reasons, people not liking Kubernetes or whatnot. It was just simple fact they didn't understand Kubernetes well enough or knew its architecture. So idea, instead of giving up, it was just to, I need to move closer. Idea was that through research, POCs, demos, show why this would be a good idea for everyone to adopt. So please note, I don't have any dedicated move or migrate to Kubernetes time at this point. I'm busy with many other things. So luckily for me, in ING, we have something that's called mastery or study days, where every 2 weeks we get to spend 1 day working on an idea or concept that you could maybe use in your work in future. And this is where I would, for example, do a research and a POC and demo of MLP v2 working on Argo CD and how that would look like, or if we were using Helm charts, or if we were using Ansible customized instead of Ansible, or that we didn't even need Ansible in the new setup. And I also used every opportunity to demonstrate how existing problems can be fixed with Kubernetes. I distinctly remember how around this time, a lot of team members, including myself, were bothered by containers crashing and then remaining in that failed state until you literally went there manually and brought them back up, to the point that we are about to start working on something that could represent, developing something that could represent a reconciliation loop for Docker. And I remember saying, like, but this is already a feature in Kubernetes. Like, what's going on here? And then we had a big one, at least for me, which was attempt to go to the public cloud. Now, as you might have had a chance to hear from my ING colleagues today, Diana and Thijs talk, things are in very desirable state in ICHP, or ING Container Hosting Platform, which we did evaluate as one of our targets and back in 2020s. And some things were still rough around the edges. We didn't like the whole namespace as a service concept. We thought it was very limiting to us as a platform and that it was more tailored toward applications. Also, some of the features which I demoed, like Argo CD, that was not possible due to compliance issues, but regardless, all of these things didn't necessarily make it our first choice target, which is a shame because that was our only target that we could go back in ING at the time. So when out of a blue, I, as a lead SRE, am given a choice one day, hey, if we're going to Kubernetes, where are we going to go? ICHP or cloud? I said, cloud. And as part of this decision, within a single sprint, I created a fully working POC of MLP working on GKE, Google Kubernetes Engine. Everything worked. We could call models. Everything was encrypted on GKE side. Everything, there are stateless workloads, so no data persists anywhere on Google infrastructure. Even the in-transit traffic is encrypted. I documented the whole thing if anyone in ING wanted to recreate it for their setup. I documented to my team. I demoed it to a bunch of other teams and interested parties. And just when I was ramping up to make this a success story, whole thing was forced to be shut down. So why? Well, since in POC we used dummy data, and in production we would be using actual ING customer data, and even with everything being encrypted, a law dispute called SHRM2 is what stopped us in our tracks. I won't get too much into it, but the gist of it is that it makes handling data between EU and US companies a lot more complicated. And while some other Dutch and European banks don't have problems with SHRM2, customer data remaining in compliant and secure hands remained #1 priority for ING, which meant public cloud was a no-go. Please note, this was back then. Things are now better. Back then, we didn't even have a public cloud team. Now I'm part of this public cloud team. Things have and are moving towards better, especially as with each passing day, it's becoming inevitable that more and more people are realizing that public cloud being part of our future is just inevitable. But that's another topic for another discussion. And what just happened here was definitely a breaking point for me, and I was literally this close to give up on the whole idea. I thought instead of giving up again, was the best thing I could do is just keep pushing on this idea, give more reasons, because now people could see how easy it was and how fast you could deploy with Kubernetes. And the whole thing was now generating a lot of traction. And those are, by the way, like some of the reasons that I use. So for example, nobody on the team liked doing any VM or any other maintenance or risk work. So when I demonstrated to the team how if we went for a managed Kubernetes solution, we don't need to do any of these things, this got likes from everybody on the team. It's also worth mentioning that Kubernetes comes with a lot of great features out of box, like HPA, horizontal pod autoscale, VPA, vertical pod autoscale, cluster autoscaling, service discovery, reconciliation loop I was talking about before. And these are basic features. This is not advanced stuff, which means that then you don't need to spend time creating your own tooling, because we are going as a platform. Just around this time, we realized that we need a service discovery. And even creating our own was in the cards, but we ended up going for an existing solution. But this still took a lot of our time, and we had to do a lot of re-architecting to make it part of our setup. And with Kubernetes, service discovery is just there. One of ING's global ambitions is to go green. I would even use this as an example. In current VM setup, we had VMs running on servers which are on all the time. In Kubernetes, you could scale up and down depending on the workloads, so you're going to consume less energy. Your whole energy footprint is going to be smaller. Even the costs are going to be less. And then we as a team also had these discussions, like hypothetical situations. If we went for a public cloud, how would that work? Just for us to realize that we're not very mobile in an existing VM setup. And with Kubernetes, once all the deployment services are part of the YAML files or Helm charts, in this form factor, we could move anywhere, on-prem to on-prem or cloud to cloud. This was a big positive realization for the whole team. Excuse me. So, parallel to all of this, what's happening here, as part of my private life, Auto CPU Frac, one of my open source tools, is trending as #1 on Hacker News pretty much the whole day. So happy days. Well, sure, but under the load, my private blog went down because people are coming to see what the project is about. And why am I even talking about this now? Well, because eerily enough, my private setup was very similar to what we had in MLP, where I had containerized workloads with a bunch of services, part of the Docker Compose files, which are then deployed to VMs using Ansible. And although I was using AWS, which is like synonym with scalability, since I was using AWS Lightsail, I didn't have this feature. Even in cloud, I couldn't scale. And at the time, I was working on the WP-Kates project, an open source project that offers you prod-ready, fully scalable and highly available WordPress for Kubernetes. Because fun fact, WordPress by default is a stateful workload. As such, it's not going to scale on Kubernetes at all. So this is something I was working on if I ever wanted to move to Kubernetes. So since I had a project that was almost finished, since I had a cluster that was shut down, I thought, what better time to prove the proof is in the pudding to myself, to my team, to everybody. I simply started the cluster back up, simple DNS change. And since WP-Kates project had horizontal pod autoscale, cluster autoscaling, it automatically scaled the cluster and pods to accommodate all the incoming traffic automatically. The scaling issue was fixed within minutes. Result of that was WP-Kates project, which was targeting GKE at the time. Just something to help people get started with WordPress on Kubernetes with being fully scalable and highly available. If you're interested, take a look. Of course, when I realized how much this is going to cost me to run a private blog in GKE, and I had like 2 Synology NAS with around 48 terabytes of data, I thought, why don't I just get a couple of Raspberry Pis and I make my own little private cloud as part of my home? And that's what I ended up doing. I extended the WPK's project to also a private Kubernetes offering. I extensively documented everything from which UPS I bought, which Raspberry Pis I bought, which SD cards, why I chose Ubuntu and microcates. Because the idea was here that I don't want to maintain this thing, that it runs as automatically as it can. And yeah, and if you go to that blog post right now, it's being served from my home. And depending on how many you go there, it will automatically scale. And since you're in Amsterdam and you might enjoy a beer or two, highly recommended, by the way. Another workload, another project that's hosted on the same cluster is Amsterdam Toilet Urinal Finder, available on atuf.app. Just something to keep our city clean, all right? So back to reality. I went to the team, I shared the news. I think this even happened over the weekend, and they were impressed with what is fixed the scalability issue. But all of it still remained to be one of those like cool story, bro. And that was it. The decision in this time and point in time is that we still remain running in current setup. Meanwhile, the platform is growing. More and more time is needed to keep the lights on in the old setup, to the point that the tenant features are not getting developed, how much time it took to maintain the old setup. And then we had an influx of a lot of big models that requested a lot of our time in terms of hardware resources and just engineering effort. And that's when we hit our old nemesis, which is the inability to grow in current setup. To keep growing as a platform and to keep scaling, options were simple. One, we hire more people just so we can scale, or number two, we hire more, we move to Kubernetes, and then we don't have to do half of the things that we're doing now. And this is when it was clear, crystal clear for everyone on the team, migration to Kubernetes is just inevitable. And that's how our decision was made. So let that sink in. Once the decision was made, it was as simple as creating a design page with acceptance criteria and scope of work, what we want with this migration, what we don't want with this migration, what can be done now, what can wait for later. And big part of it was concluding research where we want to migrate. So public cloud was still not an option. And this consisted of creating a big research document or a Confluence page, which extensively compared the both options and even had a pros and cons list between them. So options were ICHP, which we evaluated in the past, and a new kid on the block, which is a DAP Kubernetes cluster, which is now the biggest cluster in ING, the biggest Kubernetes cluster in ING. So option one was DAP, which had vanilla Kubernetes, so it meant that we could have any feature that we wanted. It had dedicated NVIDIA GPU core, so if we had a model that was onboarded that requested custom GPU support, we could give it to them. It was part of our area, so it meant that we could develop it or heavily influence the direction of its development. So match made in heaven? Well, not really, because us taking part in its development meant that we would have to continue to do maintenance and development work on this, which is something we were trying to avoid. Also, this cluster, although biggest cluster in ING, is only targeting the dev workloads. And for us to keep our integrity rating as a platform, we will need to be running in 2 zones. So if something goes wrong, that we could just have an active failover. And option 2 was ICHP, which we thought was not a good option for us in the past. Now, after we had acceptance criteria, because it didn't have some of the features we wanted, now we figured we don't even need those features for now. It was stable, it was running in multiple zones. It handled huge portion of our risk and maintenance work, and it simply came down to ticking more of the checkboxes on our acceptance criteria, and was the option we went for in the end. And at this part, it was just do it, because everything that was demoed or researched as part of the mastery days. We knew exactly what we wanted, and now we're just putting it all together. So some of the takeaways from the whole journey. As with every migration, the best approach is to keep running into setups in parallel. So don't try to extend your existing environments. This is going to be a completely different landscape. Just start from scratch. Once you verify that everything is working in an old setup, simply switch the traffic over and shut the lights off in the old setup. And monitoring, good monitoring and alerting will go a long way. I'm saying this because this is easily put aside. Besides being alerted if something goes wrong in your old environment, you also want to know if something went wrong in your new environment, especially in your new environment, so you don't just keep building on top of something that's already broken at its core. And be brutally pragmatic and stick to the vision and what was decided. Once the migration started, we had all kind of crazy ideas. But we also, for example, wanted to rebase all of our container-based images to a different distribution. Don't do this because when things fail, and they will fail, you want the blast radius to be as small as possible so you can debug it easier. And I'm also saying this because, trust me, there were a lot of options that we could have went for. And if we did, I wouldn't be here giving this talk. We would still be busy doing the migration. And journeys will take time. Over 2 years is what took for us. And I don't think our setup is that complicated. So depending on the amount of the complexity of your setup and the size of your environments, it might take even longer. That just do it step in the previous slide took like 3 months. So please note, good things will take time. And perseverance and not giving up. There are so many ways to just give up in the whole process. It was very tempting even. But while adhering to this, not giving up and persevering, you also need to keep reevaluating the landscape, but with an open mind, so you don't miss certain opportunities because your view was too narrowly scoped. Perfect example is ICHP, which we thought was not a good option for us. Now it was the best option at this point in time. Even with the private cluster, I tried doing the same thing with Raspberry Pis before. It was just not a good experience. The hardware was not up for a job, and now it was. And maybe that's one of my biggest takeaways from all of this, that keep in mind that everything changes. Certain ideas along with certain circumstances will match the changes in the landscape, and it might lead to a perfect storm as it did in MLP's case. So that was our journey, and why, for all of those of you still running in VMs, why I think with Kubernetes, resistance is futile. So thank you.